Our notes today are going to help us with the notations that are going to be used in Algebra 2. So if you look, there are notes on interval notation, and I'll touch on all of these, and there are notes on how to do set notation if you need to refer back to those. So here's what we're going to look at. Number 1, state the domain for the following graphs. So first, if you look at this number line, and you were going to write this in inequality notation, which is an additional notation we have to know. Inequality notation. You would say that this graph represents x is greater than or equal to 0, because 0 is the circle's colored in, so it's equal to. That's your inequality notation. That's probably one you're really familiar with. Set notation, I'd call it it's the fancy notation. I think about you're setting a fancy table for your inequality. So this is what it has to look like. X is a member of the set of all x's such that. That's a lot of fancy stuff that's explained in this box up here. And then I just include my inequality. X is greater than or equal to 0. And close my brackets. So set notation. X is a member of the set of all x's such that, and then you put your inequality. Interval notation is the one we're going to use the most this year. So after this test, it's pretty much going to be everything in interval notation. So this one in interval notation, we just read it from left to right. It starts at 0, and it goes on forever to infinity. 0 to infinity. Now 0 is included, so it's going to get the squared off bracket. Included, closed circle, gets the bracket. Infinity is never included, so it always gets a parentheses, because infinity is not actually a number, so infinity always gets the parentheses. So that's an example of how interval notation is going to work on that one. Let's look at number 2. Notice number 2 is in 2 sections. We have this section, a gap in the middle, and this section. In inequality notation, we put the word or to represent this gap in the middle, and I'll show you what to do in interval notation. This piece on the left, closed circle at -2, and everything to the left. So I'm going to say x is less than or equal to -2. The part on the right, open circle, and then on to infinity. So on the right, that is x is greater than 1. There's my inequality notation. Set notation. We're going to do the same thing we did here, the fancy piece. X is a member of the set of all x's such that, and then you state your inequality. X is less than or equal to -2, or x is greater than 1, and close your set. That's all there is to it. Interval notation. We have 2 sections. In interval notation, we use a union symbol for or. So we're going to read it from left to right. If I'm starting here, I hit this arrow pointing to the left. That's going to infinity, and then I stop at -2. Actually, that's going to negative infinity. So this one goes negative infinity to -2. Now remember, the infinities are always going to get parentheses, and this -2 is included, so it's going to get a bracket. The gap is going to be represented with a union, and then I pick up this side, 1, and then on to positive infinity. Now, is 1 included? No, because it has an open circle. So it gets a parentheses. Infinity always gets a parentheses. And there we go. The U is only used, the union, in interval notation. Infinity is only used in interval notation. In inequality notation, we use the word or. All right, next up. This one, notice there's no gap in the middle. It starts at -4 and it ends at 2. -4 is not included, but 2 is. So in inequality notation, I would put -4 is less than x is less than or equal to 2. This is technically an and. We'd say x is greater than -4 and x is less than 2. but it's so much easier to combine them into this one. When there's a gap in the middle, you have to do them separately with an or. But if it's everything in between the two numbers, you can do your and this way. Set notation. X is a member of the set of all x's such that -4 is less than x is less than or equal to 2. And close your set. You just have to remember all the special things before the inequality. Interval, from left to right, I go from -4 to +2. -4 had an open circle, it is not included. 2 had a colored circle, so it is included. So interval notation is going to be your friend because that's a really easy one to represent. All right, number 4, inequality. Everything smaller than or equal to 3. There you go. Set. X is a member of the set of all x's such that x is less than or equal to 3. Close your set. Interval. If you start from the left, you first notice the negative infinity because it's pointing to the left, and then it stops at 3. Infinity always gets the parentheses. 3 gets the bracket because it's included. All right, now we're going to deal with a domain and a range. Remember, your domain is the set of x's that go from left to right. Your range is the set of y's that go from bottom to top. So let's start out by looking at the domain. If I go from left to right, I see an arrow pointing to -infinity, and over here I see an arrow pointing to +infinity. Is there a gap in my x's? Well, this is a closed circle at -1, and this is a closed circle at -1. So there is no gap. -1 is completely covered. So for my set notation, I'm going to say that x is a member of the set of all x's such that x is a real number. This fancy R represents all real numbers. It's just a shortcut to saying all real numbers. That's how we represent all real numbers in set notation. In interval notation, all real numbers goes from -infinity to +infinity. Don't forget your parentheses. The range. The range is going from bottom to top. So if I start down here, I see that's pointing to -infinity. But what's happening in the middle here? There's a gap. So remember, we're going to use the word or to represent our gap. So my range, if I'm just looking at the y values, is from here down, and then it just goes straight across there. So this one is going to be, now be really careful, your range is always y's. Y is a member of the set of all y's such that, what am I, less than or equal to 1? Or, now the only y value involved here is a 4. So I'm just going to write y equals 4 for my second piece. Y is less than or equal to 1, or y is just equal to 4. We used an or because there was that gap and we needed to connect the two. In interval notation, this piece goes from -infinity to 1, and 1 is included because it's a closed circle. Instead of the word or in interval notation, we use the union. And since 4 is the only value here, I just put the number 4 in my brackets. And that would be how I would express that in interval notation. All right, let's look at some of the things on the back page. Number 6, notice this is just a linear equation. In interval notation, all real numbers. Negative infinity to infinity, from left to right. Range going from bottom to top, again, all real numbers. Negative infinity to infinity. This question right here asks you, where is it increasing? So I'm asking you, what are the x values for what, let me say it this way, for what x values is y increasing? And we read this from left to right. So if I start here and I move this direction, are the y values increasing or decreasing? Well, they're increasing. For what x values is it increasing? Well, all of them. So the entire domain, negative infinity to infinity, is increasing. Number 7. The domain. So again, we're going from left to right. If I start here, are there any gaps in my x's? There are not, so it's negative infinity to infinity. My range. Notice your range starts here. I think that's intended to be -2, and that's +3. So the first point I come to is -2. The highest point I get to is +3. So my range goes from -2, that is a bracket because it's included, to +3. And they are both included, so they got the brackets. Now the question on this one is, where is it increasing? If I trace it from left to right, this is not increasing, it's constant. It starts increasing right here up to here. So it's increasing from -2 to +1. Remember, we're asking you what x values is it increasing, from -2 to +1. Now, is it increasing at -2? Or does it start increasing as soon as I leave -2? So -2 and 1 are not included. It's increasing in between, but at those exact points, it is not increasing or decreasing. Number 8. This one we want to write in inequality notation. The increasing part we are going to put an interval though. Domain. So go from left to right. I see the arrow pointing to negative infinity. And if I keep moving across, there's an open circle at 1, but then it gets covered in the next section. So 1 is included. There's no gap. And this points to positive infinity. So my domain is all real numbers. If you wanted to say x is a member of all real numbers, you could. Or you could just say all real numbers. My range. So my range goes from bottom to top. It looks like there's a gap right here between 0 and 4, but notice what this section does. It covers that gap because it goes down to negative infinity. So it looks like my range goes from negative infinity, and the highest point it reaches is 4, and all the gap here is covered by this line right here, or ray we should say. So negative infinity to 4. So for my range, be sure you call it a y, less than or equal to 4. Inequality notation. So where is this graph increasing? Trace it from left to right. So if I start here, well, that's increasing. But then when I get to here, that's decreasing. So I'm increasing in this section. So I'm going to put it in interval notation from negative infinity until 1. And remember, increasing, it's not increasing at 1, it's only increasing up until 1. So it gets a parentheses. All right, number 9. Set notation. So this is the fancy one we're going to practice. Domain. If I go from left to right, what do you notice? Arrow to negative infinity, arrow to positive infinity. X is a member of the set of all x's such that x is a real number. All real numbers. My range, bottom to top. The first number I get to is 0, and then it just keeps going on to infinity. So my range, remember it's a y for your range. Y is a member of the set of all y's such that y is greater than or equal to 0. So this one asks, when is it decreasing? So remember, we're going to trace it from left to right. We're going to tell the x values when it's decreasing. So if I start here, this first section of the line, of the curve, that is going down. But then once it hits 0, it starts back up. So it's only decreasing from here up to 0. So I'm going to call that negative infinity to 0 is where it is decreasing. All right, one more. This one's also practicing set notation. Our domain, if I'm going from left to right, notice -4 has an open circle, and then everything gets covered until I get to +4 with a closed circle. So x is a member of the set of all x's such that -4 is less than x is less than or equal to 4. That's what this represents. Now my range from bottom to top, the lowest number I've got here is 0, and then the highest number is 4, and I've got to decide, is 4 included? Because there's an open circle that gets covered. So yes, 4 is included. So my range, y is a member of the set of all y's such that I'm going from 0 is less than or equal to y is less than or equal to 4. Then the question, where is the graph decreasing? If I trace it from left to right, the first section was going down, the next section was going up, so it's decreasing from -4 to 0. Again, neither of those points are included because it's not increasing at that point. So there are some notes on notations that should help you catch whatever you missed if you weren't in class today.